Hi, I'm Scott Lowe with Actual Tech Media. I'm here today at Pivot3, where I'm joined by John Spires, who is Executive Vice President, and Mike Kaponen, who is the Director of Product Marketing. Gentlemen, thank you for having us in your offices today.
You bet, Scott. Great to have you here.
So we want to talk about architecture. We want to talk about some of the design decisions that Pivot3 has made around hyperconverged infrastructure. But it's important to understand from a baseline perspective what hyperconverged infrastructure really is. John, can you tell us a little about the history of hyperconverged and sort of some of the high-level things people need to understand about hyperconverged to understand architecture?
It's had a long history, but the fundamental pieces of hyperconverged are you're basically converging your compute, your storage, and your virtualization in a box. It's a data center in a box. And the whole incentive behind doing this was to simplify management, because historically you had separate servers, your networking and your SAN, and then you would load your virtualization on your servers, connect your SAN through a switch. And it was very complex to configure and manage and load applications. And usually had a team managing your storage and a different team managing your servers, and maybe even a different team managing your virtualization software. Hyperconverged aims to converge all this into a box. Now there's also converged out there, which is separate systems, but the software is easier to manage the separates. And the hyperconverged is true, everything running on a single server. And there's a lot of design considerations going into this. Obviously, performance, is a key consideration because you're converging everything into a system. How well does it work? How easy is it to manage? Does it scale? Is it reliable? And all those kinds of things. And that's where Pivot3 really shines.
So when we think about Pivot3's place in the market, and as far as from a architectural standpoint, tell us a little bit about what you're doing to differentiate yourself from everybody else that's out there and how you're taking hyperconvergence sort of to the next stage.
When we started as Pivot3, we set out to address, 3-4, what we saw as key customer challenges. One was, how do they address the growing storage requirements? That always turns up to be one of the number one concerns of CIOs and people managing the infrastructure. So we wanted to give them efficient storage utilization. Second was we had to meet the performance requirements of the particular applications that they were deploying, whether it be video surveillance, databases, business analytics, virtual desktops, etc. And then the third was it needed to be really resilient. We wanted to take and ensure that the system was going to always be online, and even if there was a fault, that we were going to take and still deliver adequate performance for the applications that the customers are running. And then the fourth was we wanted it to be dead simple to manage and use. Particularly early on when we deployed systems into the video surveillance space, there wasn't a lot of IT system management expertise in that community. So initially we set out to make it to be simple for that customer to use. And then as we got into other use cases where there were vSphere administrators there, we wanted to make it easy for the vSphere administrator to take and manage all the hyperconverged infrastructure.
So what are some of the technical elements that are present in the Pivot3 platform that enable those aspects that you just talked about?
One of the key areas where we excel over our competition is the management of mixed workloads. So scale-out systems there's a lot of software in the background managing your system. When nodes drop out of a cluster, you need to be able to still continue to run, add new nodes to the system, and restripe data. And a lot of these features and functions that happen behind the scenes impact the performance. It could impact the performance of your workloads. And you're running multiple simultaneous workloads. For example, you may be running file and print. You may have 2 or 3 SQL databases. You may have an Oracle database. You may have, file and print, VDI, a VDI workload, which involves boot storms and things like that. So you have all these mixed workloads running because it's shared infrastructure. You're running multiple applications simultaneously. And a big problem that the industry has faced, even back in the SAN days when you had multiple servers running multiple applications, sharing a shared SAN, one workload could stomp on the performance of another application, right? When everybody comes in the morning, boots their desktops, that bootload boot storm, if you're running SQL reports during that boot storm, obviously those reports are going to slow down. So the key challenge that we set out to solve is how do you manage this complex mixed workload environment and give consistent performance to all those applications simultaneously. And we do that with what we call quality of service. And also we architected our data path so we can manage each application's workload independently and give it the resources it needs when it needs it. And we can prioritize those workloads with our QoS. We have three categories: mission critical, business critical, and non-critical. And depending on how you categorize your applications, the system will dynamically deliver resources to those applications to meet those business needs. And this is a true differentiation in the market, and we believe we're the only ones that have this capability.
And so what kinds of benefits are customers seeing from the deployment of this quality of service engine?
A couple of things, Scott. One is it boils down to simplifying the amount of time that it takes for an administrator to manage the performance aspects of the systems. We actually did a report a couple of years ago with about a dozen customers where we interviewed them and asked them, how much time does it take you to manage the system to meet the performance needs of your various applications with quality of service versus before when you didn't have it. And so that study showed that customers saved, on average, $100,000, per year in system administration costs, per system, over the lifespan of a year. So it boils down to, taking less system administration time to manage all the complexities of storage. And then the second area is, just in having a better end user satisfaction, because you're able to ensure that the most important applications, whether they're customer-facing applications or internal applications, are going to deliver, the performance expected, when it's most expected as well. So there's just a better end user satisfaction element to the benefits as well.
Yeah, and another big benefit is, historically customers have overbought their systems to manage those peak workloads, right? And now that they have QoS, they can manage those peak workloads and prioritize resources and dynamically allocate resources so that they can buy a much smaller system and still meet those peak demands.
Yeah, so they're able to basically start with a system that meets their immediate needs and easily scale and still meet those without having to massively over-provision, which saves money on the acquisition cost and also saves money on the scaling cost because you're not having to go through a lot of pain to scale the environment.
Exactly.
Yep. So, Scott, to continue on with some of the architectural design considerations as well. So from day one, Pivot3 took this approach of using a distributed scale-out architecture. So the hyper-converged solution is based upon clustering multiple nodes together based upon the compute and the storage requirements customers have. And so we have an architecture that takes and pools all the resources, whether they're storage resources, caching resources, compute resources, into a common aggregated pool of resources that every VM, regardless of what node it resides on in the cluster, gets the benefits of all those disk drives, global pool of cache and such, versus with some of our competitors, the resources that VM primarily has access to is the resources just within a single node. And so that limits the performance that VM can sustain. Versus with us, we have this global aggregated pool of resources that a VM, regardless of what node it runs on, gets the benefit of that entire pool.
And I assume you take into consideration potential network latency and things like that, and the calculations you make around data locality.
Yes.
Around.
Right.
Interesting. So tell me a little about how you've leveraged NVMe in your data path. I know that's a big differentiator for what you guys are doing, and it's a pretty big deal from a performance standpoint.
Yeah, if you look at the history of flash storage, obviously, actually, flash storage goes way back to the IBM days, but it was too expensive and never got commercialized. But today, with the ability to dedupe, compress, and do all these things with flash, they've gotten the price down to where it's kind of cannibalized the high performance disk and replace that. And now, a lot of people are saying it's all flash, and flash will eventually replace disk, which I believe it eventually will. But then there's the whole story of disk is going to replace tape, but some guys are still doing tape. But in reality, a lot of these customers are seeing the benefits of flash. It has huge economical advantage for performance-oriented applications, and it's very resilient and easy to manage. But the first iteration of a flash device was, it looked like a disk drive. Right, so they packed the NAND into a disk drive form factor and put it behind a disk drive connector behind a disk drive controller. And, when I first saw that, when I first came out, I'm like, what are you guys doing? The data path was designed for a disk drive, not a flash drive.
Right.
Flash is more like memory than it is like a disk drive. So the disk controller became a huge bottleneck. And even the interface, the SAS, traditional SAS, SATA, and fiber channel interfaces to the drives, those data paths and protocols became bottlenecks, and the whole infrastructure, needed to be redesigned for flash. Well, a working group, the NVMe working group, designed this new spec that replaced all that data path to make it designed for flash. The problem is the first iteration of some of the NVMe devices are still in the drive form factor and still behind a controller.
Right.
Now, they can go direct to PCI, but it needs a lot of changes with the software and data path. And the server manufacturers and everybody's working towards that direction. But if you look at Pivot3, we started right out of the gate, flash on the PCIe bus. Before the NVMe spec was even out, we were running flash on the PCIe bus. And we've designed our whole data path around that. And we do our read-write caching, directly to flash. We don't go through a RAID controller or any of that stuff, which makes our performance better than anybody else in the industry and reduces latency and all the overhead associated with some of these other architectures.
I think the other thing I'd add to that, too, Scott, is that NVMe data path and the multiple tiers of storage media in the system is all managed and controlled by that quality of service engine. So the quality of service engine, based upon the performance policy that the customer assigns to a volume or VM, knows where to place data in the NVMe, PCIe flash tier, in cache, or on SSDs or hard drives, based upon what's necessary to attain the performance policy that's set. And it's always looking and making decisions in real time. Where's the best place to place blocks of data, move blocks of data to ensure that that performance policy is met. So it's, there's this unique kind of, interoperability that goes on in real time between the tiers of storage media and that quality of service engine, that makes us unique as well.
Yeah, what's really unique, like Mike said, the quality of service engine can dynamically tier data, and it depends on how many tiers of storage you have in your system. You can have disk, we even support SSD, traditional SSD behind a controller. We have the PCIe NVMe flash, and we have RAM as well in our system. So our QoS can dynamically move data between those tiers to hit on a performance requirement and a service level requirement. And that's truly unique. And we do that globally. It's a global cache across all nodes, which makes it very unique as well and gives you that great performance when you need it.
One of Pivot3's big customer bases is surveillance companies, right? How is this NVMe data path and the QoS engine, how is it benefiting them as well as some of your other customer segments?
The video surveillance is really interesting. Video surveillance is one of the killer apps for hyperconverged infrastructure. And Pivot3 discovered it first. A lot of our competitors start out in data center applications and didn't even think about video surveillance. We kind of started in video surveillance and said, wow, the hyperconverged infrastructure works great here because you can run all your VMS software on different VMs across nodes. And then you have great ingest rates from video, so you can support thousands of cameras simultaneously. And it's all really easy to manage in a single platform, multiple nodes. All your storage is virtualized, your compute's virtualized, and your software VMS instances are all centrally managed. And it makes it great for people that may not have deep skill sets in IT to stand up a video surveillance storage system.
So, Mike, early on in our discussion, you mentioned data protection resiliency. How is Pivot3 going about addressing that, or has addressed that in the platform from an architectural standpoint?
Yeah, that's an interesting one, Scott, and kind of goes way back to the roots of Pivot3. Because we saw that customers in the spaces we were serving just struggled with. I've got these growing storage requirements. How do I meet that from a cost, a budget standpoint, a scaling standpoint, et cetera? And then is to do that while at the same time having a resilient system, and if they suffered faults, how do I keep data online, accessible, and still accessible in a high performance fashion? So from day one, Pivot3 has utilized erasure coding to provide customers high storage efficiency rates, as well as maintain data availability in light of there being a failure. So right now we're on our 8th generation of erasure coding. With it, using it as a data protection scheme, we can achieve up to 94% storage utilization rate. So if a customer needs 100 terabytes of storage, we can give them 94% usable, and then customers can have their data available and accessible even in light of there being up to 5 simultaneous drive failures or complete node failure within a hyperconverged cluster. And even in those failure scenarios, we're still able to sustain over 84% of the normal performance. And so we're able to give customers this combination of resiliency, performance, and high storage utilization rates using our patented form of erasure coding.
Let me ask you a question about your erasure coding methodology, because one of the things traditionally we've heard is erasure coding is beats up on a CPU pretty significantly. So how are you handling erasure coding in a way that doesn't take a lot of CPU away from workloads you're going to run on the platform?
Yeah, we designed our erasure coding way back when, and we've refined it for years now. Everybody says they have erasure coding, but in reality, they really don't have inline erasure coding. Our competitors are always doing it after the fact. They'll write data in Merit, and then in the background, they'll restripe it with erasure coding. And that background operation, by the way, can disrupt applications and kill quality of service. A lot of customers end up turning off erasure coding on competing products because of the performance overhead. We do it all in line, and we do it in cache. So we have flash cache where we do a lot of our erasure coding calculations. We've taken advantage of the CPUs and doing those calcs in the CPUs. And we only have about 10% overhead on the CPUs for our whole stack of software. So, if you look at our CPU utilization, our speed of erasure coding, our efficiency of erasure coding, we clearly lead the market. We have lots of patents on this. We have over 30 patents related to this. So, it is a strong area of IP for us, and it's beautiful, and it works in a lot of applications. One of the reasons we're a leader in video surveillance is we can erasure code the video because you can't compress or dedupe video, and we can erasure code it across nodes, and it gives us the best storage utilization efficiency in the market. You translate that into data center IT of database workloads, file and print, all the traditional IT workloads. We do the same thing. We erasure code it across nodes. It's very high performance because of our use of flash, and it gives you that great storage efficiency and resiliency that Mike talked about.
Do you do data reduction?
Yes.
On the platform? So you're combining that with erasure coding and getting, especially with the better utilization you get from erasure coding, so you're getting some pretty impressive, I would imagine, density from a data perspective when you combine that with data reduction technology.
And the data reduction is in line as well. As John mentioned, the erasure coding is all in line too. So it's efficient from that standpoint too.
A lot of our competitors will use LZ compression and different off-the-shelf technologies to do that. We have our own patented technology that actually looks for data patterns, and if we see it, recognize the data pattern, we won't even store the data. We'll just update metadata, and then when we read it back, we just calculate it from the processor. So it actually increases performance and improves your efficiency at the same time.
What kind of reduction ratios are typical? I mean, obviously on video, we're not going to see it, but I mean, what are you seeing on average from a customer perspective when they're looking at databases and sort of line of business apps?
Usually it's 5-to-1 in a lot of instances. It really depends on the workload.
Absolutely. Very good. Well, we can't have a discussion anymore about architecture without talking about cloud. It's a thing. So how is your architecture lending itself to helping support public cloud and hybrid cloud scenarios and people's desires to sort of get outside the bounds of the data center?
Yeah, we're in a world of multi-clouds these days,
yes.
aren't we? Yes.
Yeah. The cloud is really interesting, and it's obviously it's moving very fast, growing very fast. There's a lot of customers asking about it. In fact, every customer you talk to, how you have a discussion around cloud and kind of things that they're looking to do on cloud. The big the big challenge with cloud is, which cloud do I use for which application, and when, and what's a typical, and then how do I set it up? There's lots of APIs out there, moving one of your applications in VM and its data to the cloud isn't trivial. Mm-hmm. A lot of times you have to learn the management of that cloud provider, how to set stuff up, install it, manage it and all that kind of stuff. So, and then if you have some on AWS, some on Azure, some on Google, now you have 3 different platforms you have to learn and manage, and APIs and all that. It can get overwhelming. Our goal is to provide that single management layer that allows you to manage your data across multiple clouds. And with the QoS, and the ability to orchestrate everything across clouds and understand the cost models too. A big problem is, it may cost you X dollars to run this on AWS today, but if Microsoft comes out with a new service that is less than that, there's no visibility into that unless you're, reading the latest and greatest. If your software was able to go out there and look at what the different different providers charge for a certain application or workload, and dynamically move your data across the different clouds to optimize costs, that would be ideal. So we think that the future is going to be the single stack of software that does tiering across clouds, gives you real-time costing information, recommends new services if there's a cost advantage, understands performance and which tier of class of service you need for different applications, and then tells you when to keep stuff on-prem. The dirty secret with cloud is, ingress is free, but egress, right. Reading data back, that's where they charge you all your money. So if you have an application that's heavy read workload, chances are you're going to pay a lot of money, and you should keep that on-prem. Mm-hmm. And then there's security implications, regulatory implications, and all those kinds of things. And to have software that's intelligent enough that has insight to all those variables and can make recommendations for you and actually move data around for you is going to be the killer app. And we're well on our way to delivering that.
Yeah, and Scott, the reason that we're well on our way to delivering that is we're leveraging the IP that we have in this policy-based, quality of service engine that we've spoken about a couple of times, because that gives us the ability to take and tier data between multiple types of storage media, whether it's on-prem or off-prem, and then we have that orchestration engine, that knows how to intelligently, in real time, move data between, the different storage media types based upon the policy attributes that the customer wants to attain or adhere to. So that kind of has given us a leg up on kind of going the direction that John said, because we've already have some of those foundational elements in place, and they've been in market and in customer use now for 4, 5, 6 years.
So when we think about a hybrid cloud scenario with Pivot3, are you running natively in the cloud, or are you running on a Pivot3 instance in the cloud?
Yes.
Okay, so both. You support both. I assume that from a data migration standpoint, it's easier to move from on-prem Pivot3 to a cloud-based Pivot3 stack, so you don't have to do any kind of translations of the workloads. Is that correct?
And we'll do both. We'll have our software running in the cloud, and so Pivot3 will be talking to Pivot3 software running in the cloud in some instances, and in some instances we'll be talking through the APIs of the cloud providers into their services. But we'll all make it transparent for the user, and a single interface that does both and makes it transparent.
Gentlemen, thank you very much for having us in your offices today and for having this great discussion.
Thanks, Scott. Appreciate it.
And thank you to our audience for watching this video.